Hi, welcome to Lunch and Learn with the Pensacola Mess Hall. We'll get started relatively soon with our guest speaker, Annika Evans. So we'll wait for a few people to join us and then we'll get started. I'll let Tina give me the go ahead because as I'm sharing my screen, I can't really see much. So,
If folks are at their keyboards or able to, I think it might be interesting if you could share whether you tuned into the other sessions with us. That I recognize some names. Did any of you attend the first three sessions that we had?
that's right, this is session 4.
Mhm. Julie says they attended all 3 previous sessions. I do recognize your name. Welcome back. Thank you.
Awesome.
Did you decide what your spark bird was? Rebecca, same question. Did you, I'm curious what people think their spark bird is. Or if you don't have one yet, maybe one will come along.
I think I finally remembered mine, Tina.
Oh, yeah?
It was pelicans. So I am older than you. And I remember a time when brown pelicans, you didn't see them a lot. Environmental reasons. I bet Annika knows a little bit about why some of the pelicans are not around. But I remember seeing a much larger flock of pelicans when I was, well, at least in my teens. And that I remember researching why I was now seeing pelicans. So,
Mine is the osprey, the mating pairs and how they talk to each other from a distance to let each other know they're coming and going. And the fact that they're just so beautiful, that was I recognize that bird. I want to see what these birds are doing. Very much my spark bird. Melinda said she attended Kelly's talk on the coastal dune lakes. And Rebecca said cardinals and the red-winged blackbird. Yes, those are beautiful. The fact that we have cardinals here amongst all of the green tropical foliage, when you kind of associate cardinals with like as a winter bird amongst evergreens, it's kind of fun. It just feels like our own little, special bird, despite it being like a Christmas bird. Cardinals for Julie as well.
cardinals are such a striking bird with the red color.
So maybe when people think of Florida birds, they think almost strictly of seabirds and tropical, parrots and things like that. But they're little songbirds and blue jays and things like that.
Mockingbirds.
Yes, very, very prevalent here. All right, I think we can go ahead and get started because we have a pretty good cohort here today. Melinda said black skimmers. Yeah, those are definitely really cool birds. We learned about those too.
Oh, there's some on the beach nesting already by the water, well, not the water tanks, not the water towers. But anyway.
They're fun.
So as we get started, welcome to Lunch and Learn with the Pensacola Mess Hall. I'm Sarah Beth Gordon, the Education Director, and co-hosting with me today is Tina Inman, who's going to be doing some of the things in the background for us today as well. Tina is our Marketing Director, so if you may interact with her for getting some of the word out and on our Facebook page and Instagram as well. So just letting you know, community engagement has become a much bigger thing for us at the Mess Hall. We are moving into a new location right now. And it's made us think a lot more about our community partners who are out there doing math, engineering, science, and stuff. Bringing back to that stuff, I guess this time could actually be the archaeology that we learned about last week. So I hope that we're reaching you since we're not open yet, but we are opening soon because, and I'll tell a little bit more about that. So we have one more Lunch and Learn after today, and that will be with Christian Wagley with 350 Pensacola and the Healthy Gulf. And we'll learn about climate action. which is really cluing in a lot of what we're doing, because birds are affected by the climate and coastal dune lakes are affected by human activity, as well as all the storms around here. And then we learned about just how delicate um, archaeology sites are and how they are affected by our changing climate and with weather. Um, and then Annika is going to bring in some more things about environmental remediation. We were chatting right before this started. I'm excited to hear more. Give you just an idea of how this is going to go. We'll talk a little bit about what's new at the mess hall. I want to touch on our Bring Back Science campaign. I'll introduce our speaker and we'll get onto that. I believe Annika brought like a little hands-on activity that you might be able to do if you have time, or perhaps you can do it later. And then we'll have some time at the end for questions and answers. So as I mentioned, we've been closed. We've been doing outreach the entire time, but we have a new location at 418 East Wright Street in downtown Pensacola. It has been exciting the past 2 weeks. We have moved, we have painted things in. We're moving things around and doing some more painting. Moving locations is expensive, and it also requires us to get in experts to say, cut a hole in the wall, make sure the roof is sound, make sure we have good environmental systems. So when you walk into them, the air is circulated well and not getting too hot or too much humidity. And we are a nonprofit, and we rely on our donors to help us bring math, engineering, science, and stuff to our community. So I'd like to highlight our Bring Back Science campaign, and we're doing this through GoFundMe. So GoFundMe.com, Bring Back Science. And this is Dolores from a couple of years ago at our homonograph, which we just moved back into the building. Again, we had to do things like rent trucks and paint, get a new air conditioning system. So all of these things, you would help support our mission to bring problem solving and creativity through the lens of math, engineering, and science. So thanks for letting me talk a little bit about the mess hall. But what I really want you to learn about today is Annika Evans. She's a chemical engineer, and she is going to be talking to us about environmental remediation. And I'm just going to let Annika get started. I'm going to stop screen sharing, Annika. I'm going to mute myself and let you have the floor.
Awesome. Thank you so much for having me. So I'm going to go ahead and share my screen then. And we'll get started. So as Sarah Beth said, my name is Annika Evans, but you might still see my maiden name floating around out there for a little while. That's Annika Beaupre. So a little bit about me. I have a Bachelor's of Science in Chemical Engineering from the University of Minnesota Twin Cities. And if you were like me before college, you don't really know what chemical engineers do or what kind of jobs they have. But in general, they design and operate chemical plants, or they work on processes that convert raw materials into useful products. For example, a lot of chemical engineers go into oil and gas, where they take crude oil out of the ground and they convert it into diesel, fuel, or useful lubricants. Some people go into food manufacturing. This is my friend Blaine, and he is a process engineer that makes donuts and cakes and pizza. You might go into pharmaceuticals. Oops, here we go. Like some of my other friends from college. You might go into plastics, where you mold plastic into useful materials. A couple of my friends from college have gone into nuclear engineering. You might be a research scientist. You might make biomedical devices. There's lots of different options. So I personally interned with an oil company in college. Can you see my mouse here? Or do I need to turn on you can? Perfect. So you can see me here in front of a natural gas vaporizer. It was a very big piece of equipment I was using for my internship project. After I graduated from the University of Minnesota Twin Cities, I became a manufacturing engineer where I made microchemical reactors, which you can see in the bottom left-hand corner here. They were very small. They were about the size of my thumb. And now I work as a chemical engineer that creates processes and technologies that clean up environmental contamination. It's also referred to as environmental remediation. So what is environmental remediation? Basically, it's the removal of pollution or contamination from the environment. And that can include removing contamination from soil, groundwater, surface water, sediment, and even the air. So the first step in environmental remediation is identifying a potential release. And you might be looking at this picture right here of this oil spill and thinking, oh, that must be so easy. I can see it right there. It's not always the case. Sometimes people spill things and they don't want to tell you. Sometimes the chemicals that are spilled are odorless and they're colorless, so you can't see them, you can't smell them. And other times we store fuel or chemicals in underground storage tanks, and we can't visually see them when they crack and they start to leak. So once you've identified your potential release, you would go out to your site and you collect samples. You would collect soil or groundwater, and they even have methods to collect the air. And then you would send those samples back to the lab, and the lab would run tests. They would analyze them, and they would let you know, yes, there are high levels of pollution or certain chemicals in the sample, or no, there were no chemicals in the sample, and there probably wasn't a release. So if there are high levels of chemicals or pollution in your samples, then you have to come up with some sort of engineering solution. Down here at the bottom left-hand corner, you can see me standing in front of something called an air sparge system. And naturally within our groundwater and within the soil, there are bacteria. They're also referred to as bugs in the industry. And when you add oxygen, like this air sparge system would do, the bugs start to grow and multiply, and they're very hungry. So they start to eat up the contamination in the groundwater and the soil. So at the end, your air sparge system will result in clean groundwater. So from your engineering solution, you get to a clean site where you can swim in the water, you can drink the water out of the ground, you can roll around in the grass. So why is it important to remove contamination or pollution from the environment? For starters, many chemicals are harmful to human health. There are a lot of chemicals that are carcinogens, which mean they cause cancer. There are chemicals that damage the nervous system, they cause lung damage or organ failure. And in addition to human health, chemicals can be harmful to animals and to the environment. Two very famous examples of this are DDT and Agent Orange. DDT actually softened the shells of birds' eggs to the point where the baby birds actually kind of cracked out before they were fully developed. Agent Orange, you can see it kind of on the left-hand side of my screen here. They used to spray Agent Orange over trees and vegetation, and it would kill or kind of get rid of that vegetation. They could see better what was on the ground, but it actually caused permanent environmental damage. And in addition to the environmental damage, it also caused horrible health effects to the people who lived in these areas. So if human health, animal health, and the environment can't convince you to clean up contamination or pollution, maybe the law can. So CERCLA, or the Comprehensive Environmental Response and Compensation and Liability Act, also called Superfund, was passed in 1980. And basically it identifies sites where hazardous material has been spilled or stored. And then it identifies who is responsible for those spills and storage. And it keeps those people responsible for the cleanup and for mitigating any health risks. In addition to CERCLA, there's the Clean Water Act, which keeps pollution from migrating into our waterways, including rivers and lakes. And there's the Safe Drinking Water Act, which keeps contamination and chemicals out of our drinking water. So I have a little video here that kind of puts all of this into an animation. And I'll kind of talk through this as it goes, but naturally groundwater flows underneath our feet, and it usually flows in the direction of a lake or a stream. You can kind of see the water particles moving here. So the water underneath our feet is usually held in an aquifer, which is just a big giant void in the ground. Water will filter through the ground and kind of be stored here naturally. So cities and homes will pull their water from these aquifers using wells. And when the water is pulled, it will kind of pull the water down into a V shape, which you'll see here. and in the home, it does very similar thing, but a smaller V shape. And then the water that is not sucked up into a home or into city water will flow out ultimately to a lake or a river or a pond, something of that sort. So as I mentioned before, some people will spill things. For example, this company has spilt some solvent into the water and has actually leaked through the soil and has gotten into the aquifer. And when this happens, you actually have globules of solvent that can move through the aquifer and get sucked up into the city's water or into your home water, which it'll show here. And I had also mentioned that sometimes we store fuels and chemicals in underground storage tanks, which keeps it out of the way, but it also makes those chemicals closer to the aquifer if there is a leak in the storage tank. So you'll actually get contamination moving again into your homes, or if it passes past those wells, it will ultimately make its way to a lake or some sort of body of water. In addition to having groundwater contamination, different types of gases inside of an aquifer can actually start to vaporize. They turn into a gas, and then you'll have gas issues up in your basement as well as water issues. So I primarily deal with groundwater contamination and groundwater remediation, kind of like was shown in this picture. And most of my treatment systems will start with some sort of filter. It'll start with a multimedia filter, a sand filter, or a cartridge filter, which basically has an insert that is made out of some sort of mesh or fabric. And these filters will filter out the larger materials before it gets sent to the rest of the treatment system. So what do these filters do? This figure kind of shows what a filter would do. These larger circular objects represent rocks or grains of sand. And these clumps are kind of like the larger clumps of contamination or sediment that you would be filtering out. And the clumps are too large to make it all the way through all of these cracks and crevices and spaces in between the filter material. So the only thing that can come out the other side is clean water. But what happens when your chemicals or contaminants are so small that they slip through those spaces with the water? There's a couple of different things you can do. You can use heat to break down the chemicals. You can use different types of less harmful chemicals to break down the chemicals or to bind to them. But a lot of the times we'll go to absorption. So there's two types of absorption. There's physical absorption and there's chemical absorption. Physical absorption is when the media inside of your have really weak interactions with the chemicals that you're trying to take out. They stick to the absorption material almost like tape or glue. Sometimes the physical absorption material even has crevices or pores inside of it that the chemicals actually physically gets trapped inside of. Chemical absorption is when the chemicals that you're trying to remove from the water actually interact with the absorption material and they bind to the absorption material and are kind of bound there for forever. And then once your water has passed through this absorption material, all the chemicals should be stuck to or bound to your absorption material, and all that should be left is clean water. So one very common type of absorption material that we use is granular activated carbon. It's also referred to as GAC. And up here, you can see a picture of what it usually looks like. It's a very dark black, almost like a rock or gravel type material. And you can see a picture of how activated carbon actually works. It's very porous. It has a lot of crevices in it, So chemicals that you're trying to remove from the water actually get stuck inside of these crevices and these pores, and the clean water continues to move past the top. So some systems are very, very large. These are some GAC columns that we would use on an industrial scale, or for example, an entire business or school that had water issues. They can be larger than a house and they can be wider than a person. But you can also put absorption materials and filters straight onto your faucets and into your homes. So here's just a picture of one on a faucet. So another thing that I did want to mention is that your filters don't always have to be in a vessel. You can get really creative with the way that you configure your filters and where you put your filters. So for example, this figure on the left shows what's called a permeable reactive barrier, which basically means it's a filter with material in there that reacts to certain types of chemicals that you're trying to remove. So this is actually just a wall inside of the ground. And as groundwater flows, it either gets stuck on this side of the wall or it gets caught by the reactive material within the wall. And once you get to the other side, you should have treated water. A lot of times people will put PRBs, is what they're called, kind of upflow from a well or from a lake so that none of the contamination continues to migrate into those sensitive areas. Another example is a sediment control curtain. So basically what you do is you put a big shower curtain type of material into a lake, and it'll actually hold back the sediment from migrating further into the lake and causing the water to be turbid or mucked up, I guess is a better way to say that. So if you're really excited about filters like I am, you can try this activity at home. What you're going to need is a plastic bottle or a couple of plastic bottles, dirty water. You can take dirty water from a pond, or if you don't have a pond, you can make your own dirty water. You can crunch up leaves from your backyard. You can add some cooking oil, maybe some coffee grounds to the water, and just stir it all up. And then you're going to want some filter materials. I would suggest trying gravel or rocks, maybe sand. You can try a coffee filter or different types of fabrics, maybe cotton balls. And you can set up these plastic bottles with your filter material inside of it and pour some water in and see which ones do the best at filtering. Sometimes if you add multiple different types of filter materials to one filter, you'll be able to filter out not only the large pieces, but the small pieces and keep it from getting clogged. So I would take my time and just try all the different filter materials by themselves and then try combinations of the 2 or 3 or 4. And then there is a link if you're really excited about the filter materials. National Geographic does have a step-by-step how to make your filters and what materials you need. So you can always look on their website. But that is it as far as filters go. I am more than happy to take any questions about anything.
Great. Well, Annika, I will give you like a quick time for you to like take a sip of water if you need to.
Yes.
And I just looking at those water filters. So as somebody who does the hands-on science at the mess hall, we have made those water filters at the mess hall and really played around. We made our dirty water so that we would know what was in it, so that we could measure what we got out of it, so we could see what it looked like before and after. I think it's also super cool because the plastic bottles that they were cut, well, you could actually use those to make rain gauges, which makes me think about some of our citizen science, which I'll talk about in a little bit. But I see that we do have some people that have some questions. So
let's see if I can pull up the question view.
I can read them to you. So like, Do you see, oh, microplastics in groundwater? Microplastics are a big thing right now because we know that they get into the air. And we know that even when plastics do break down, they're very small, those little microplastics. So what do you know about microplastics in with environmental remediation and what you are doing?
So we don't typically see microplastics in groundwater. That's probably because you have to make it through many layers of sediment and clay to get into the aquifers. It's mostly chemical contaminants, but we do have a team at my company that is working on microplastics in the oceans and along kind of along the seawalls and those communities that are right there on the oceans, because microplastics will ultimately get into their water treatment plants and either start to pile up and cause filtration issues, or they will go right through the water filtration plant and into people's drinking water. So that is an issue. We do have a team working on that as we speak, actually.
So one of the things that I noticed as you were talking about solvents might go from, say, an industrial site or whatnot. And I'm a chemistry minor, and so I know that water is called the universal solvent. So can you talk a little bit about how things that do migrate down and filter down, because it's also stuff is filtering from the earth, our surface of the earth down into the ground level. So our earth causes a lot of filtration as well, but that what the problem is and how many things are dissolved in water.
Yeah, some chemicals aren't technically dissolved and they'll stay kind of on the surface of the aquifer, which makes them a bigger issue for small private wells, home wells, because those are pulling from the shallower part of the aquifers. But you will get a lot of drainage. If you spill something on the soil, for example, fertilizers and stuff, that will make its way down into the aquifer and it will mix in the aquifer and become dispersed. Sometimes that's a good thing because then you're at a lower concentration of contaminant. But if there's a lot of contamination and it's completely dispersed within the aquifer, that means that it's causing a whole lot of different issues for a whole lot of different people, even if it's in smaller amounts.
Okay. Let's see. Carrie was asking, what if I don't have a basement?
A basement for,
Like if there's, I'm thinking going back to the gas, like gasoline.
oh yes, vapor intrusion. So vapor intrusion does occur on the ground floor as well. It's worse if you have a basement, obviously. I wouldn't worry about vapor intrusion in your home unless you've been contacted by the state or you've had some sort of spill in your area that you could think of that would be of volatile materials. Um, it's and it's not a huge issue in the south, again, because there's very few basements. But up north, if you do spill something and there is vapor intrusion into your basement, that is an issue. Let's see here. What else do we have? Kind of scrolling through here.
Yeah, so there's one question that says, with the curtain-like barrier for a waterway, does it hang the full depth or do they use a weighted bottom? What is the engineering needed to get that to conform to the shape of that waterway? That's
Yeah. So the a lot of times they do have some sort of weight at the bottom of them. They won't usually use the curtains in very deep open waters. It's mostly in channels and along the shoreline of lakes. The engineering behind it's actually not that difficult to engineer. You have some sort of mesh that is going to hold back anything of silt diameter or larger, so anything big, and let through your water. The real engineering comes into determining the measurements and the depth of the water, and then buoyancy, keeping it up, because it will sometimes you'll get a heavy material that you can't always float. So you have to put some sort of flotation device on the top of it. You have to do the calculation and determine, if you do put a weight on the bottom of it, how heavy does that weight have to be to keep the curtain straight up and down. You have to be worried about any type of rope or chains that you're using to suspend it across the channel, because you don't want any type of wildlife to get caught up in that sort of thing. And you have to worry about how you're going to bolt it into the shoreline and keep it there so it doesn't float away. And again, cause some wildlife concerns with different types of birds and sea animals getting caught up inside of it. It's a combination of not just engineering, but I would say also speaking with our archaeologists and our geologists and our biologists, and making sure that something that we put into a lake or put into a natural area doesn't cause complications for that habitat and for the animals that are living there and the people that are living there.
Okay, so not just engineering, but biology as well, and chemistry. So so when I have one question in particular about you, and then we'll get back to some of the other questions. When you are deciding to become a chemical engineer, what is the balance of, say, when I think of engineering, I think like all those physics things, and then when I think of chemistry, I obviously think of molecules, organic chemistry, and analytical chemistry. What was the balance of classes that you took to get this degree?
I would say it was about 50-50 chemistry courses and then physics and engineering courses. You have to have a good background in chemistry to understand what you're doing in these chemical plants and the type of things you're trying to treat and you're trying to produce. But ultimately, at the end of the day, you're usually dealing with problems on more of like a mechanical level or a physics level. So you have to understand that the plastics or chemicals that you are creating at the plant are sensitive to heat, or that they can corrode piping. But at the end of the day, you're going to be the one ordering piping and sizing pumps and determining, how much pressure you need to flow the plastic through the pipes and how much heat you need to melt the plastic. So there is a background in chemistry, but a lot of it comes down to physics and mechanical type work.
Okay, all right, cool. A lot of math too, then.
A lot of math.
All right. I always say when kids ask me, like, oh, do I have to do math? And I'm like, math and science are best friends. And engineering is that intersection of math and science. So you have to know quite a bit of it with the physics and the math. So, all right. So we have another question. Or how often do you do remediation with septic tanks that leak in rural communities? And do you use the same technology you mentioned to clean it up, or are there different challenges with these septic tank issues?
Yeah, we don't have a ton of septic tank issues, at least at the company that I work for. Again, we're doing a lot of chemical spill work where I'm working. But you would have to think about different methods and different media that you can use to absorb to any type of contaminants that are leaking from the septic tanks, because unlike PFAS or VOCs or PAHs, which are chemicals, the things that you're trying to remove from that might not bind the same way to the same types of materials. So you wouldn't necessarily put a GAC system in to remove any contaminants from a septic leak. You might have to go and find maybe some sort of bacteria or something that you can put into a tank that could eat up that sort of, those sort of septic related, I'm going to call them chemicals still, but your septic tank is more of like a biological concern than it is a chemical concern.
Got it. Okay. All right. So Julie would like to know is how much does soil, water, or air temperature impact the size of the particles and possibly the effectiveness of the filtration?
Yeah, that's a really, really good question. It really does affect some of the filtration materials. We have some materials that we can't let get above 104 degrees because they'll expand too far and they'll actually break the tanks. Some materials can't get too cold because they will crack and they will fracture, and that will kind of defeat the purpose of having pores. The soil isn't as big of a problem with temperature fluctuations. Water and air, that's when you start to get into, if water freezes while it's inside of your treatment system, that's not a good thing. If vapors start to vaporize and turn into gases, then you have to deal with capturing the gases in the air, which is a whole different ball game and a lot harder to do than capturing things in their liquid state.
Ah, okay. All right. So Melinda would like to know, oh, okay. So when you're filtering and doing the absorption of materials when they're used up, how do you dispose of responsibly
That's
these
another
filters?
good question. I
Yeah,
like these
that was on
questions.
my list, Melinda. So thank you, because I was like, what do you do when it's full?
Yes. So once they have absorbed to their capacity, they're all their little absorption sites are filled up. They can't bind anymore. There are certain resins and materials that they are making now that you can actually regenerate, which basically means you would flow some sort of solvent across them and break those chemical bonds or lift them out of the crevices of the absorption material. And then you would be left with kind of a concentrated solvent and contamination batch, I guess you would call it. And then you can actually incinerate that and burn it at very, very high temperatures that will break the carbon bonds or break the bonds within the contaminants. Otherwise, people will just incinerate the absorption media itself. So they will put it in a fire at 450 degrees Fahrenheit or higher. It depends on what the chemicals are attached to your absorption material, but at high enough temperatures, you should be able to break the bonds of those chemicals. So incineration.
Okay. All right. Okay. So we have somebody piggybacking on Melinda's question. Are there places where filters are used over a large surface, like to protect the environment, and those need to be dug up and managed regularly?
Yes, so there are filter mats that you can put places. I've seen people, they basically put their filter material into like a wrestling mat type of a thing, and they will lay it across a field or they will lay it at the bottom of the river. And as the water runs, the chemicals will get pulled into that mat. Those types of things will need to get pulled out of the river and incinerated or disposed of at a hazardous waste disposal site. Um, as far as I think you're kind of referencing a PRB, which is what we kind of talked about earlier. As far as the PRB goes, sometimes they will remove the media out of a PRB and leave the frame of it inside of the ground. So all you really have to remove is the media. Sometimes that media is biodegradable. So once it's done its thing, it's reacted and broken down. The chemicals that you're trying to break down, it will disintegrate and it will go into nice natural carbon type compounds. So yes, regular management, you're on the site all the time, making sure that things are not breaking down too quickly, making sure that things are not getting rolled up on accident, making sure that animals obviously are not getting stuck in that sort of thing. So yes.
I imagine it's a balance, because some people I can imagine, like, outside people don't understand that, say, your job, your company's job is to clean up a mess, and all they see might be
Oh,
it that you have somehow made a mess. So I suppose there's some type of balance there.
yes. The most important thing, I think, when it comes to remediation is that when all is said and done, we do our best to, reseed the site and try to restore the natural vegetation and the natural plant life and really try to leave it more beautiful than when we came. People feel a little less upset at you if you make sure that after you've cleaned up the water, everything looks nice and neat and and taken care of when you leave.
Yes.
So we try very, very hard to clean everything up, to make sure there's no garbage floating around while we're there, to make sure that everything is marked off with safety markings. And if we need any type of containment to keep the wildlife out of that area, we'll definitely spend the money to do that and make sure that everything is done, by the book.
Okay, so if there's a seawall near an industrial site protecting a water source nearby, what is that made of? And are there special properties, or is it just concrete? Yeah, that's what they said. Is it just concrete?
A lot of the times it is just concrete. A lot of times they will just, drill a rectangle really, really far into the ground, and it's just concrete kind of holding back any migration of chemicals into the bay or into the ocean. You can get fancy with it, and you can put reactive material into it and hold it back with some sort of mesh, or hold it in place with some sort of mesh. But a lot of times when you see a seawall, that is just concrete.
Okay, all right. Okay, so Melinda says possibly only related tangentially, but is it true that Pensacola has one or more cleaned up Superfund sites?
Yes, Pensacola has a lot of different sites that they have been working to clean up contamination on, mostly related to NES Pensacola, Quarry Station, and Softly Field. And you can actually, they have a website. You can go and search, NES Pensacola Environmental Program or Installation Restoration Program, and you can read through what each site had. It can be anything from VOCs to heavy metals and how they took care of that or how they're monitoring it. And they will actually share data with you, and share their plans with you. And if you're really interested and you're part of the community and you really want to know what's going on in your community, they do have community meetings. They have public meetings, where all of the environmental contractors, like my company and the Navy and NAVFAC, which is Navy Facilities Command, they'll all get on a call, or they'll all meet at a conference room. And anyone who wants to can come and provide input or ask questions, get their questions answered. Maybe we're putting in a new treatment system, or we're going to excavate some soil that had some contamination in it. We'll always have a public meeting before that. And if you're worried about maybe knocking down trees, or you're worried about, this farm is right next to NES Pensacola, how is that going to affect this farm? You can ask all of those questions. They are more than happy to answer those questions.
They probably would like people to ask those questions.
Yes. The more people that come, we aren't just sitting there waiting for questions. It's nice when there's lots of people there who are obviously very interested in their community.
So I was going to ask this one as well. So I'm used to hearing the word a Superfund site. Do you know why we call it Superfund?
That is a good question. I actually do not. I like to refer to it as CERCLA, just because that is its actual given name. Superfund, I think it comes down to like the financial part of it. These sites are usually millions and millions of dollars worth of contamination cleanup. They're usually extremely hazardous. You wouldn't call something that had maybe a small oil leak a Superfund site. This is something that had some serious issues. I don't actually know what Superfund comes from. I bet I could look it up though.
Yeah, that might be a little scientific history lesson with a little governmental policy thrown in as well.
Oh yeah.
All right. Well, I'm going to take just a quick break. I'm going to share my screen so that you can have a little moment, because again, I was watching the filter that you were making, and it made me think of, you can make your own rain gauges, and that hooks into our citizen science. And a way for our audience now to get involved is to look out and look for some of those ways to get involved with the quality of the water around you, and to understand what people like Annika and her company are doing to clean up our waterways, and to make sure that these VOCs is volatile organic compounds, correct?
That is correct.
Okay.
You have VOCs and then you have VOCs, which is semi-volatile organic compounds. But there's a lot more different chemicals out there than just VOCs and SVOCs.
Right. Well, it's to keep all these chemicals out of us and out of the fish and the shrimp. I think a lot of us around this area love the shrimp that are in this area. We really do not want to be eating all of those things because that's what the shrimp live in. But I did want to get another way for people to get involved is to also join us on our citizen science. And we are doing this through scistarter.org. And you can go /NOAA-the mess hall. And this is a way for you, just using your device or even a laptop computer, of seeing the change around you. So you see that you can click on two different, I'll move my cursor around. You can click on I see change here and sign up at SciStarter, and then click on I see change. And it's an app that you put on your phone. And it's like you take a nature selfie. Typically, we're talking about weathering the storm and extreme precipitation, which we haven't had around here, but I know a couple of neighboring states over, they're having lots of different rain events and flooding issues right now. So you could take a picture of that, post what's going on in your neighborhood, so that policymakers and decision makers can see the change that is going on around us. Right next to it, I'm going to move my cursor around so you can see, you can buy a rain gauge if you'd like to, but you can actually make relatively accurate rain gauges to measure how much rain has been falling. I mentioned that I made one, and a couple of days ago we're still having like the wind right now, but I actually brought mine in so it wouldn't blow away again. And this is just using a plastic bottle and some weights, scissors, and you can make your own rain gauge. It's really easy to get involved. You can see like what the IC Change app would look like. You can just write down what you see. If you're terrible at taking pictures, then don't take a picture, just write down what you see. You can click what's being affected in your environment. Is it oceans and fresh water, or is it skies and air? And then you can click on the weather as well. And then you post that sighting, and you can see what other people are posting in the area as well. And then what do we do with that? Well, we use that, we share that out so that people can see, like I said, policymakers can see what's going on. So I hope that you join us with IC Change. I've got it. I haven't been able to use it lately because we haven't had any rain, which has been taking pictures and thinking and seeing, well, it's not raining, there's not any changes. I do live near the water, so I do pay attention to all of the things that are going on. And but I hope people do join us with IC Change. It's a great way of doing it. And I know that Tina did pop it in the chat of how to get started at scistarter.org or /mess hall. So I was going to see if anybody had any more questions. I'm trying to see if there were things that I wrote down, but I think everybody came up with all of my questions too. The one thing I wanted to talk about, you were saying that there are filters that you can use on your faucets. And it brought to mind all of those different water pitchers that you can buy. And is that activated carbon or charcoal in there?
Some of them are. You'll get a lot of filters with silver inside of them, and that's an antimicrobial. I'm not sure if you have city water, if you really need to have the additional filter. I use filters just because it tastes better to me personally. I'm not too worried about what's coming out of the Pensacola city water. But yes, a lot of them do have activated charcoal inside of them. The filter that I use in my pet's water bowl, that's all activated charcoal or carbon. So very common.
So some of the filters that are used in aquariums also have charcoal in them.
Some of them do. Yep. Yep. And you can have, like I said, there's lots of different resins, and a lot of people are putting a lot of money and research into resins and absorbents at this point. So there's always new companies popping up with slightly more innovative, slightly, more sticky, as I like to call it, resins that bind better to different types of chemicals. And you can get them specifically for your needs. For example, if you have an iron problem, there are companies out there that make filters specifically to stick to or bind to iron. Lots of different options. Again, though, City of Pensacola water, I just drink it straight from the faucet.
So it's more worried about like if you had well water that you would want to.
Yeah, we most of the issues you see are with well water just because they're on their own system. They don't have the whole filtration that you would have for city water. And a lot of times they're in more rural areas or they're by more industrial type areas. So that is where you get those types of accidents.
Okay, cool. So Tina, do you have any questions that I might have missed in the chat box? I really love the questions that people asked.
No, same. I saw more than one question I had written down get asked in the chat, so that's fantastic. I have a lot more curiosity about the topic in general, and it's kind of renewed my awareness of how important science is in our area. And not that I'm ever in any doubt of that, but I'm so thrilled that Annika came in to talk to us about her expertise. And I hope people got something out of it and they're a little bit more aware of what goes on behind the scenes to make sure we have that safe drinking water and that the industry around us is staying safe or as safe as possible in terms of keeping the environment healthy.
Mm-hmm. And I really appreciate it, Annika. I'm gonna have you. I know that you'll be leaving our area soon, but I am gonna have you zoom on into some of our camps to feature women in engineering as well as some of our waterworks camps. We were talking about that. We were also talking about the environmental aspects of this as well, and that just really very happy that you have joined us and educated me on some other things. I think I knew some of this, but I know I didn't know all of it and everything that was going on. So I really do appreciate that. Just remind everybody, please tune in next week where we meet with Christian Wagley from 350 Pensacola for our last Lunch and Learn. And remind everyone that the mess hall will be back open June 1st. I'm super excited about that. You're getting a lot of thanks, Annika, for your time. We really do appreciate it. Because we have gone, as Tina and I often said, we've got this little motif going through that we did not plan. We were simply looking for people that were good at talking about what they do, but everything from the birds to the coastal dune lakes to the heritage around us that Mike was talking about last week, to the quality of our water, because we all want clean air, we all want clean water. That's for all of us. And then next week we'll be bringing it all back to our climate, so our climate connections. Thank you, Annika, again, and thank you, Tina, and thank you for everybody with your excellent questions. Definitely wonderful listeners out there. So thanks a lot, and we'll see you next week.
Thank you. Thanks for having me.
Goodbye.